So we'll be starting in a moment, guys. So good afternoon, all of you. We welcome Dr. Diganta Mukherjee to Chinta Statistics Department, and Sir has done his PhD Kolkata in economics, but before that, he has also done his BStat and MStat from ICFAI Kolkata, and a long 10 years. So yeah, that's like really long and a lot of experiences. And then Sir's worked a lot of projects in and abroad, in like India, outside India, in government sectors and corporate houses. And after being a faculty at JNU and abroad universities, he is now a faculty in ISI Kolkata. So, without further ado, I will hand over the screen to Sir. And on a personal note, uh, he has been a very good mentor, and he's also now a very good mentor of mine during my hard times. So, yeah, thank you, sir, for your acceptance. And yeah, we will not take this too long, and we'll start this soon. Thank you, sir, and the screen is yours. Welcome to Chinta
Okay,
Statistics Department.
all right. Thanks, Vijit. Good afternoon. Uh, Let me start by sharing my screen. Yes, okay, okay, okay. So, if I have done it correctly, then you should be able to see my first slide. Srijit, is
Yep,
it showing right? Yeah.
perfect,
So,
perfect, sir.
yes, so I'll be toggling a little bit because I would like to move to some other sites in the course of the lecture. But let me begin at the beginning. So this talk today, which is titled A Gentle Introduction to Statistics for Finance, is essentially targeted to undergraduate students in statistics who would like to understand how finance is connected to whatever they are studying right now, which would be statistics, along with some mathematics and maybe some computer programming. So my job today would be to show you that finance relates to statistics in various ways. Not only that, there are some interesting things to do in this domain. So before I move to the statistical applications or actual analysis topics, let me first show you a little bit of the financial market. So it's a very short tour of the financial market because some of you may not have any awareness about the financial market, how it operates, and more importantly, what should you look at. So the main organized financial market of the country is the National Stock Exchange, which is usually called NSE in short form, abbreviated. It is now a completely online platform, so there is no real exchange hall where people go and trade. There is an exchange building, of course, but that is only for official purposes. All the actual trading happens online. So if I were to go to this National Stock Exchange website, which should now be showing on your screen, this is how it looks like now. Of course, the format keeps changing. They keep redesigning the website, but this is how it looks right now. This is the National Stock Exchange website with different tabs here that tells you about how the market operates, what is the data, where you should invest, how to trade, the regulations that are relevant to the market, etc. So to show you a little bit of a snapshot, let me just scroll down. So this is the current value of the stock exchange index for us, which is known as Nifty 50. So this is the Nifty stock index, which is nothing but a combination of 50 major stocks or shares. Current value is standing at 14,886.15. So if you refresh the screen, these values will keep changing because this is a real-time screen. Continually, you will see these values changing. You can also see whatever has happened through the day today, starting from around 9:15 in the morning when the trading starts. The Nifty 50 index has been moving up and down like this. We are currently at 4 p.m. or 4:05 p.m. and this is the current status. It is not updated in real time. This is updated up to 3:30 at this point, but it will get updated with a lag. So this is the stock exchange index. On the other side, on the right hand panel here, you can see some of the individual stocks on which you can see the current values. So the Tata Motors, the current price is 323.45, Titan 1610.30, etc. And again, all of these numbers will keep updating. Okay. So that is my stock exchange. Now, in this stock exchange, suppose we were to discuss particularly about the stock prices. There are many other things which are traded on the stock exchange, but just to keep the discussion focused, let us only talk about the stock share prices, which is also called equity. So the equity is listed on this link here, which I will again move to on my internet tab, and the page is loading. So this is a page which you can arrive at from the main page of the National Stock Exchange, and here you get more detailed data on all the stock indices like Nifty 50 as well as the major stocks, the major shares of the companies. So you can see some columns here which are the actual data, the opening price, highest price today, lowest price today, and yesterday's closing price. And this last one is the last traded price, the price at which the last transaction happened. So this is how the stock market displays the data. And you can see that there are quite a number of stocks that are listed here. But of course, this is not all. There are many more, but this screen is showing you the major ones. So if I want to zoom in to a little bit more specific context, suppose I want to understand about the stock exchange index, Nifty 50, and in particular, I want to understand how it has performed over the last 1 month or over the last 2 months. I can do that coming to this screen now, which is showing this is the historical data. Here, I have to select my index. I already have the Nifty 50. Let me not change it. I want to select a time period on which I want to see the data. So suppose I select 1st January and I select 23rd March and I say get data. So I have asked the stock exchange to show me the value of this Nifty 50 index from 1st January of this year up to 23rd March. This is showing wrongly. This has to be March because 23rd April has not happened yet. This is how the data is shown. Again, I have the open, high, low, close, these values for every day, which is not every calendar day because the stock exchange is closed on the weekends. So all the weekdays from 1st January up to, actually it is showing up to 8th April. So you can see the historical data as well, which would be very important for students because this is how you get hold of the data for any statistical analysis that you may want to do. Okay, so before I move on, let me just quickly check if there are any questions.
No,
Sujit,
so there is no question over here. So you can continue.
I'll continue.
Yeah,
So,
I will be helping them to like I will be helping you to ask you their questions if they have any. So you
right.
can, yeah.
So this is how the market look like. Of course, I
Okay,
have
so
only shown.
there are some questions. There is
There
one
is a
question.
question.
Ashish has asked that how are the weights calculated for the Nifty 50?
Ashish, this is going to take a long time to explain. Let me give you the short answer now. The short answer is that 50 most important stocks are assigned weightages depending on how many shares are traded on it over the last 3 months. So it's a weighted average. The weights are selected based on the volume of trade over the last 3 months, and this is revised every 3 months. The details are, of course, available on the National Stock Exchange website. On this website, you can go to the About page and find out how the stock exchange index is calculated. Okay?
Yep. So I think you can continue. Okay. So
Yeah,
people,
let me go.
another question is there. What is the meaning of close price, open price, and that thing?
Right. So let me go back to that screen then.
Okay.
Okay. So let us look at the historical data. This would be easiest to explain. So on 1st January at 9:15 a.m. the market opened, and the first trade happened at this price. So this is called the open price. And at 3:30 p.m. on that day, the market closed, and the last trade that happened was at 14,018.50. So that's how the open and the close are determined, the first trade and the last trade. And during the day, this was the maximum value, 14,049, where the index was traded. And this is the lowest price, 13,991, at which the index was traded. We do not know exactly when it happened, but it has to happen between the opening time and the closing time. For every day, we have as such opening, closing, also a high and a low. So is that,
Perfect.
yeah?
I think that's. I think that is quite a good answer. I think Shine has understood that. We can continue. There's some statistics related question. I think we can continue with that question after we started discussing the statistical aspect. So,
So,
sir, you
so
can
there is a
continue with
question from Projot, which is very general, so we can discuss it later, I
yeah.
suppose. All right. So that is more or less a very short overview of what the stock exchange look like, what is the data, a very brief glimpse, but now you can find out if you are curious, and also how to get hold of historical data, data from the past, with which we will do our statistical analysis. So with that introduction, let me now move on to a very simple probability kind of model. So this model looks very simple to be useful in any real life situation, but let us see. It's a very naive sort of model, but you have all seen this model. In any probability stochastic process textbook, there are simple examples like this. So let me begin at the beginning. Suppose today the stock price, whatever stock I am interested in, the stock price is currently valued at S0. This is the starting price, and I know what the price is. I am interested in finding out what might happen tomorrow. That's what I want to know. Of course, I don't know. I am guessing, or in statistical language, I am trying to predict. That's the problem. So the simplest possible model for prediction of stock prices works like this, that I assume that tomorrow the price will either go up by a fraction u, or it will go down by a fraction d. So u may be 5% up, which is like 1.05 times today's price. D may be 3% down, so it is 0.97 times today's price. So again, as I said, it looks like a very simple model, does not look realistic at all, because I have only allowed for two possibilities. But you will see that this model is actually quite useful for our purpose. But
Sir,
just
sir, one thing.
yes,
So I personally think it will be really good if you just mention this idea that for those people who are not from finance background, that what is the why will people really be interested in the idea that a stock price will go up or down? Like what will happen? Like what does it mean? Like why is it good that stock price will go up or good that it is go down? So can you just explain on the non-financial for those who are non-financial
yeah, of course.
people over here? Yeah,
That's what I will do in a couple of slides.
sure, sure. Okay, fine. Thank you.
But good that you mentioned. I will keep that in mind. So let me just want to talk about the model and then try to connect and also tell you why is this important. Why am I at all bothered about it? Okay. Now I was in the earlier slide where I just talked about the stock price, which can move up or move down, but that is not good enough for us. These are two possibilities. Even if these are the only two possibilities, I need to know more. In particular, I need to understand what are the chances of its moving up or moving down. So let me add on some probability element here. So suppose we say that the price of the stock will move up to S naught U with probability P, and it will go down with probability 1 minus 2. P, U, D, all of these things we will have to put specific values for. We will see how these values are to be calculated, but a little bit more about the model. Let us look at an example with numbers. Suppose my S0 is 20. So I start with a stock price which is 20. And I say that tomorrow the stock price can increase by 10%. So U is 0.1, or the stock price can move down by 10%. So D is 0.9. So from 20, tomorrow I can go to either 22 or 18. So on a good day, I will go to 22. On a bad day, I will go to 18. What happens then? The same things get repeated day after tomorrow. Again, I can move up by 10% or I can move down by 10%. Even if I am already down, I can go further down by 10% or I can move up by 10%. So every day, the same 10% up or 10% down story can continue. And as you can see that even though I have only drawn this as a two-step example, there is no reason why this has to stop here. I can think of the next 30 days. So I will have 30 steps here. But what is going to be important to understand is every day I only have two choices. And the choices come with probabilities also. I have not written the probabilities here, but as you can see, it is not enough to know how much it will go up or go down by. I also need to know what are the chances of it is going up. And this leads us to something that you know very well, which is the binomial tree. This is called a binomial tree. Why is it binomial? Because there are always two possibilities. Wherever I am standing, there are two possibilities open to me. If I am at 20, these are the two possibilities. If I am at 22, these are the two possibilities. So every time, every day, there are two possibilities. So it's a binomial tree. And if I continue this for longer, there will be more nodes here. The tree will fan
Okay,
out.
so there's an interesting question. Is that does the probability? Sir, you don't have to go back. I will just ask so that you
Yeah.
can stay on the slide.
Oh,
Yeah.
okay.
So the question is that is the probability remaining fixed or not?
That's a very good question.
Yeah.
To begin with, when we build up our initial models, we assume that the probability is fixed. So at least say for the next 7 days or 10 days, we assume that the probability will remain the same. But if you are really looking at very long term for the next 1 month, 2 months, or 3 months, then there is no reason why the probability should remain the same and it should be changing. We should allow it to change. So this is where our statistical analysis comes in. We look at the data, we look at past data, we see what has happened, and we try to match it with a reasonable probability value. And we try to assess whether one single value is good enough to explain the whole history or we should have different probability values. That's the job of the statistician, to find out which specification works the best.
Yeah, so that's a very good insight into that. Thanks, Ponan, for the question. And another question is that people are finding a really good resemblance to the Markov chain, and so and also like the birth process
Yeah, of
and death
course.
process.
The
So
whole
uh,
the whole of this analysis relies on the Markov chain theory,
yeah, So
and
people are asking that whether you can generalize this to an idea to a Markov chain in general. So
we can generalize this to a Markov chain in general in many directions. But let me tell you something, that even though this looks ridiculously simple, too simple for any practical use, this happens to be the most popular model, this binomial tree. Even though we are open to devise any more complicated Markov chain based model, still people keep coming back to the binomial tree model.
yeah.
Maybe there are historical reasons, but it's also because binomial tree gives us a lot of flexibility in parametric work, in estimation work.
Simple things are always beautiful. Yep.
Yeah.
So we can go ahead, I think.
So as you
Another
can,
question is that people are asking, I have already answered it. Like they are asking whether it's a two-state space, it's like continuous state space.
of course,
So yeah. Okay.
that can. So of course, as you can easily guess now that once I have done this binomial tree model, the probability calculations would be dictated by our binomial probability distribution. That is very easy to guess, and you know that the calculations will be quite simple. Now, one of the reasons why binomial tree model is so popular, because the calculations are not complicated once you have put down these numbers precisely. Okay. Now, now I'll try to justify why this model is at all going to be important for us. More fundamentally, why do we care about stock prices going up or going down? You see, the stock market actually survives because people are coming to buy and sell stocks. And why would people come? Because we, all of us, have some expectation, some anticipation about the stock prices. We may think that, okay, in the next 3 days, the price of SBI, State Bank of India stock, will go up. I have made some calculations on my own computer and I am very confident that the price of State Bank will go up. So I will go to the stock market and buy stock SBI stocks today, anticipating a rise in price in 3 days' time, when I will sell it and make a profit. Similarly, some people who are already holding some ICICI stocks may think that now ICICI stock price will start falling. From tomorrow, the price will get lower and lower. So I will go to the market today and sell off my stocks, because if I sell it tomorrow, I will get less money. So selling it today is better for me. And these are the transactions, these are the operations which makes the market work. Because there are millions of people who are trading in thousands of shares. So it is not one share, one person. Many people, many shares. They have different expectations, different calculations. Some people are coming to buy, some people are coming to sell. As a whole, the market becomes active. And obviously, if you are in an active market, then you would be very interested to know what are the probability models that can explain the movement in the stock market, not only for the stock market index, but also for individual stocks. And that's why the whole of this discussion actually started. In fact, one of the most famous examples of an application of this kind of a model, in fact, the binomial model, is the Black-Scholes formula. The Black-Scholes formula is the most famous formula for pricing what is known as financial derivative contracts. Some of you may have heard these terms like options, futures. If you ever look at uh, the stock exchange website or newspaper pages where financial market data are published. So Black-Scholes happens to be named after two persons who developed this. This is a model for calculating the correct price of financial derivative contracts. So derivative contracts are contracts which are written on price movements of stocks. So the value of this contract depends on how the stock prices are moving. And you can write different kind of contracts to give you different kinds of advantages in the market. So this is one of the important applications of this kind of binomial or any other probability model. This is now a huge body of knowledge. There are many firms which works solely on this kind of models, trying to find better models, trying to get better estimates, and trying to predict the market better. There is a huge financial sector, whole financial sector. This is used in all countries, in all financial markets. Everywhere you go, be it Europe, be it USA, be it India or Japan, anywhere. So this is a big deal.
Yeah, so
Also,
there's another question, a small
yeah,
question. Stehal is asking that how big the role of this statistical independence or probabilistic independence play in stock prices, and how do we really collate like merge the stocks in a group and make these groups independent, and or something else, or like what we really do about it?
we will get there in a while, maybe in 15 minutes.
Great, great, yeah.
So because I'm still in the background, so once we get to the actual data analysis part, we will see these questions being asked. Okay, so now before I move on to those questions, I just wanted to finish this background discussion by saying that we have these simple models and some more complicated models, but many of these models doing the mathematics is not easy. It gets more and more complicated as you build up bigger models. So most of the time we do a lot of simulation studies to understand how prices will move. So let me now also show you a very nice visual here. So this, if you can see this on screen, this is a visual on a two-dimensional stochastic process. It is actually a two-dimensional random walk. So what is a random walk? A random walk is where you can either move right one step or move left one step with probability half and half. So the simulation that you are seeing on screen is a two-dimensional version of this random walk. And why am I showing you this thing? I'm showing you this because we talked about the binomial model. The binomial model is also related, very closely related to this random walk, because we always have only two choices. One of the choice is going up, the other choice is going down. You can think of it as left and right. Of course, the probability need not be half and half, it can be different. Okay, any questions at this point on this?
No, but they're really excited by the graph, and me too.
The graph is good.
Yeah.
I always like this graph.
Yeah.
Okay, so what do we have? We have a financial market. We have some data. We now know how to access the data. We have talked about a very simple model, but you can see that there can be more complicated models. But more importantly, the simple model is the most popular one. It is used in many applications. I have given you a famous example of this Black-Scholes model. And I have also told you that sometimes we are unable to do the probability calculations on paper. So we do a lot of simulation studies. Okay. Now, let us start talking a little bit of statistics. You see, the binomial distribution or the binomial tree model that I just described seems to be a very simplistic model. Doesn't look realistic at all, because if you have seen the National Stock Exchange screen a little while ago, you will see that the movement seems much more complicated than a simple two-step model. But if I were to say that, okay, I am not talking about tomorrow, I am only talking about the next 5 minutes. So tomorrow is a long way away, many hours, but let me only talk about the next 5 minutes and try to understand how the stock price will move. And what I will do is, instead of talking about the whole day, I will think of the day as constituting of many such 5-minute intervals. Now, when I talk about only 5 minutes, if you recall the binomial model, I can claim, and you can think about it, that the binomial model for the next 5 minutes does not sound so bad. Because how much can happen in 5 minutes? 5 minutes is just a short interval of time. So if I say that the stock price will just go up by a little bit or go down by a little bit, that will describe the next 5 minutes reasonably well. If you are not happy with 5 minutes, I can say, okay, let's talk about next 1 minute. And then I can aggregate. I can take up all the 1 minutes throughout the day to get my big binomial tree. That doesn't sound so bad, right? So what I am driving at is the following, that if I think of the binomial model or the binomial distribution describing the stock price movement for a little while, that would be reasonably good, because then I can aggregate it over many steps for a day and get a variety of outcomes. So that is a plausible way of extending the binomial model. But if I do this extension, then that will slowly bring me to the realization that then I am essentially talking about the normal distribution. Because if I look at a very large binomial distribution, because if I take only 1 minute over the whole day, that will be many, many minutes. So a big binomial distribution, that big binomial distribution would look very, very close to a normal distribution. That is the central limit theorem result that we know, we talk about a lot. So if I were to say that, okay, instead of going through the binomial distribution for 1 day, then 5 minutes, then 1 minute, let us say that, okay, I only think of a very short interval of time, very small interval of time, like in calculus, dt, and my model for describing the stock price is the normal distribution. Then I am logically in the same place. Whether I talk about binomial distribution and aggregate them over a large number, or I talk directly about the normal distribution, I am logically in the same place because they are connected through the central limit theorem. Okay, so is that clear?
Yeah,
Am I
I
making
think
sense?
so. They're really understanding, I guess.
Right.
They're, yeah, yeah.
So because this is a very important argument in any probability theory or application, and it is equally important for us in the analysis of financial data. So then if we take this story aboard that normal distribution seems to be the right candidate if we are talking about binomial for a short time, so it's normal over the whole day, then my next question would be a very statistical question. Do my data match with the normal distribution? Because then the price data that I get, the historical data that I showed you, that should fit the normal distribution fairly well. And that is a hypothesis testing problem. So we need to test if normality is indeed valid. And you know that testing for a distribution, whether a data is actually following a particular candidate distribution, can be done using the chi-square goodness of fit test, or in a more general setting, in a non-parametric setting, using the Kolmogorov-Smirnov test. So are you familiar with Kolmogorov-Smirnov test?
I think some of them are, some of them may not be. Yep.
But
So,
okay, so chi-square you all know, right?
yeah, chi-square is a good point, I guess. Yeah.
Chi-square are boxes, and you fit the theoretically correct frequencies in each box, and you look at the observed frequency in each box, and you look at the gaps, and you aggregate these gaps in a particular way to get the chi-square. If the gaps are too large, then you will reject your hypothesis. Kolmogorov-Smirnov test works in a similar way. You draw the cumulative frequency distribution, which is also known as the ogive, and you draw the theoretical CDF. If these two graphs are very close to each other, then I accept my normal distribution hypothesis. If at any point the gap between the theoretical distribution and the ogive is too much, I will reject my normal distribution hypothesis. So it's the same idea, just operationalized in different ways. But they are essentially checking whether my data is close to the normal distribution shape.
Yes. Yeah, maybe you
Now,
can just tell a bit about how the distance between two functions is calculated, like that. Maybe a one line.
you
Like,
mean the Kolmogorov-Smirnov, right? The chi-square you
yeah, yeah,
already
yeah,
know.
yeah. For Kolmogorov Finland, how is the distance between the CDF calculated? So that will make.
Okay, so the Kolmogorov-Smirnov, what you do is you just calculate the cumulative frequencies.
Mhm.
So you look at the values and see how much frequency is less than or equal to that value. So on the x-axis you have the values, and on the y-axis you have the cumulative frequency. So as you go up, it will go up to 100% of the frequency.
Yeah.
The corresponding theoretical function will also give you a similar graph, which goes up from 0 to 1. So you overlay them on the same picture, and you will see that, okay, there is a red line and there is a blue line, both starting from 0 and finishing at 1. But do they match each other in between? If they match, very good, I accept. If they don't, I reject.
Yeah, some people are asking some statistical questions, but I will handle it. You can carry on with the finance stuff.
Yeah, so
Yeah.
we'll come back to them later. Okay.
Yeah.
Now, there will be two situations. One is where normal distribution seems to be quite reasonable. Then we are very happy because we know how to work with the normal distribution. But in some cases, in many cases actually in real life, you will see that normal distribution is not really describing our data. But some other distribution might be describing the data better. If it so happens, then we have many more follow-up questions. Then first question would be, how do we estimate the parameters of those other distributions? Because normal distribution is so nice, we know so much about it. But if there are other distributions involved, the story can get complicated. Also, what would then be the properties of these distributions, because these properties are going to be crucial to understand how the financial market model will work, because we are not doing it purely for a statistical purpose. We are doing it to understand the financial market better. So with normal distribution, we know where we stand. It matches with binomial, etc. But if it is some other distribution, then it's a Pandora's box. But again, this is another line of inquiry which people invest a lot of time in. What are the alternatives possible? Life is not so nice if we do not have normal distribution, because many distributions have very peculiar properties. You may have a distribution, I will show you one of them, you know about it. You may have distributions where the mean, the variance, the usual things doesn't work. The mean doesn't exist, or the mean is too fluctuating too much. The variance is infinite. Such bad candidates are there. What will you do then? You still have your data, you still have your financial market to predict. How will you go? For instance, if you see that I cannot work with the mean is not stable, I may want to work with some other measure of central tendency. When we started learning statistics, the first thing that we learned in our descriptive statistics chapter is mean, median, mode. So if mean doesn't work, maybe we'll have to work with the median. That's a possibility. But then how will you do the maths? For mean, we know a lot of results, we know all the statistical properties, etc. We don't know so much about the median. That's one important question. And even worse situation could be where I could not find a good candidate probability distribution. I checked, normal doesn't work. I checked with other common distributions, maybe log normal, maybe exponential. None of them fit my data. What do I do? In such a situation, we are usually thrown to the non-parametric methods. So if I come up with a new unknown shape of the distribution, I may have to use non-parametric methods, which is again another branch of inquiry in itself. So, just to reiterate, our logically consistent pairing would be from binomial distribution to the normal distribution, which would be very nice. We can check whether my data matches with normal distribution using common tests, chi-square or Kolmogorov's window. Trouble is, when it doesn't fit the normal distribution, what do I do otherwise? In terms of estimation, in terms of properties, in particular, we may run into bigger trouble, like we don't have the mean, we may have to work with something else. We may not be able to match a known distribution. We may have to work with non-parametric methods. Any questions here?
No, I think there are no questions over here, and I think this third year people of this college, of the undergrad college, they are just learning non-parametric. I think it's really good opportunity for them to understand this by an example.
So I'm
Yeah.
not going to teach you non-parametrics, but what I'm telling you now is where the non-parametric methods fit in with the final.
Oops, I think there are some issues. We will get back to you soon. Don't worry about that. Yeah, just give me a moment, okay? Just give me a moment. Don't worry about that.
Can you
Yeah,
hear me?
perfect. Yeah, I can hear you, and I think this is a very good opportunity for the students out here to recapitulate what they have learned for a few minutes. I think this sort of kind of break time.
Good.
Yeah,
Okay. So you
you
have a
can share
break.
your screen, Naveen.
Prajjot has already asked a relevant question. I can see that.
Yeah,
So I will go to that question in a while.
yeah,
We were talking about alternative distributions. I think that's where I lost my connection.
yeah.
And these alternatives I will come back to soon. But let me first show you some specific problems. This is one kind of a specific problem. In our statistical models, whether we work with normal distribution, we usually assume that the variance is a constant. So over the whole span of our data, I have one single sigma square. This assumption is called homoscedasticity. Homo is as in equal, scedasticity as in spread, so equal spread. This feature is often absent in financial data. So here what I am showing you is the stock market returns. Returns are percentage changes from one day to the next. The stock market returns over a number of days. And you can see that the data is fluctuating differently in different phases. Here, there is a huge amount of fluctuation, but here, all through on this right panel, there is very little fluctuation. This is another big fluctuation phase, but this is not as big as the first one, but bigger than the rest. So this situation is something that you will see very often in financial data. So what will you do with that? So is the question clear? That I can see that my data do not support this assumption of constant variance. It is fluctuating differently in different phases. So that's a very common phenomenon in financial data. I need to have some solution for that. But before I find a solution, I must first statistically check, which is testing a hypothesis, whether the fluctuation is really changing. So what should we do? If we indeed find that there is heteroscedasticity or volatility is changing, we should have a model with not a sigma constant, but sigma as a function of t, which is like time dependent volatility. Now, how will I know what kind of function sigma t I should have? I need to have some idea where it should be big, where it should be small, how much is big, how small is small. I don't know whether you have ever learned the Goldfield quant test. This is a test, a very simple test and very old one for checking heteroscedasticity. It looks at pieces of data. I look at the whole data, but I look at the first piece at the beginning of the time period, and I look at another piece at the end of the time period. I calculate the sample variance. I calculate the sigma square, and I statistically check whether these two sigma square values can be considered to be equal or not. And the test is done using an F test, F distribution based test. This is the basic check for homoscedasticity. If I see that the sigma square values estimated from different pieces of the data are close to each other, statistically not significantly different, then I can continue with my constant variance assumption or homoscedasticity. But if it indeed happens to be significantly different, then I have to have a corresponding reasonable function sigma t, which will describe my time dependent volatility. And the calculations we do in this kind of tests will help us to guess a good candidate function for volatility. Once you start working with this kind of data, you will see that very often you see heteroscedasticity, and then the first job for you would be to find a good function for sigma t. Okay. So this is the picture that I indicated from my earlier discussion here, that we work with median instead of mean or some other method. So this is one picture that I put here to highlight that point. And also to introduce you into one more issue. Okay, yes?
Yeah, so two questions are there. One question is that Ananya Pam has asked that what is like he has learned this in a regression class about homoscedasticity. So are they similar in some manner? And Bhakti has asked that what is hedging. I think we can discuss this hedging part towards the end of the video, but this linear regression part and homoscedasticity can be discussed a bit, I think, for some
Yes.
moment.
It is the same thing. In a linear regression model, the only advantage is that your data may not be time sequenced. In a financial data situation, it is time sequenced. So you talk about earlier part of the data and later part of the data. In regression, if you are working with cross-section data, then earlier, later may not make sense because the data is not time sequenced. That's the only difference. Otherwise, all the calculations would be the same. In linear regression model, then you will try to find which of the independent variables are influencing the volatility. So instead of drawing a picture, so let me go back to this picture, that will be helpful to explain. So when we are talking about this financial data, which is time sequenced, my x-axis is just time. So I look at the change in fluctuation over time. In a linear regression situation, if you have cross-section data, your x-axis will be one of the independent variables, and you try to judge whether there is a dependence on this fluctuation pattern with one of the independent variables. Does it answer the question?
Yeah, I think it properly answers that. And Ananyapam has another question is that, like in other cases of testing, like basic normal testing and stuff, we get a good sufficient statistic for the parameters. Does GQ test also give us a good statistic for the parameter of sigma t, or what is like, or is it just checking homoscedasticity by assuming like by the F test? That's his general question.
It does not give you a good sufficient statistic because Goldfeld quant does not start with a model. It does not have a model. It only talks about equal or not equal. If it is equal, then you are happy. You have a constant, so don't need to worry about models. But if it rejects, which means I do have heteroscedasticity, then GQ does not tell you about the possible model. Then it is your job to find candidate models.
Yeah, I
Of
think
course,
it's really interesting. It's a good
there
point.
are more recent tests. This is the oldest one, but because as I said, it is undergraduate, so I thought that naming too many tests would be hard. But there are other tests which also gives a model, so you do have a function. So if we have
Perfect, I
time
guess.
near the end, we can touch on that.
Sure, sure.
Now, coming back to that mean versus median case, and also to introduce to you a more general problem. This is a picture that you have all seen. The normal distribution and the Cauchy distribution. The red line is Cauchy, which is higher when you go to the extremes. The blue line is normal, which is higher when you are near the center. So which means the normal distribution gives more mass to the center, more probability to the center, very little to the tails. But Cauchy gives a lot of mass to the tails. So much so that the mean function for the Cauchy distribution does not exist. So if you happen to have a financial data which matches the Cauchy distribution rather than the normal distribution, you cannot use the mean function for any statistical work. And then you are thrown to the median. In general, this kind of models are called heavy-tailed models. So this normal versus Cauchy is one example, but there are other probability models which often fits financial data very well, but they do not have moments, some of the higher order moments. These are called heavy-tailed models. The name is obvious because I have heavier mass on the tail. So this is another direction of inquiry where if you happen to fit a model with more mass on the tail, so that maybe the mean doesn't exist or the mean exists but the variance doesn't exist, things like that, what will you do? Because you still have to analyze, you still have to model, you still have to make predictions. So this is statistics. When things are going well, when you have normal distribution, it is very easy. Then you really don't need statistics because there are already softwares there. When you are getting out of the comfort zone, that's when statistics plays a bigger role. Okay, so I will move on to multivariate, but before that, are there any other questions on this? Because this topic is going to be difficult, so I am not spending more time on this right now.
No, Ananda was asking how to find the estimate of sigma t. And yeah, the only two questions are left. How to find the estimate of sigma t and hedging. These two questions are left, which you can answer now or maybe afterwards.
You can answer later because I just want to show you the multivariate analysis because the regression is something that we are so comfortable with.
Sure.
So let me talk about a little bit, at least, about correlation and regression and how they can be used for handling financial data. So suppose now instead of one single price series, I have many stocks to study together. I want to actually handle all the 50 stocks which are in Nifty 50 together. I can do that. Multiple shares to study. And study means I want to look at the linkage between them because the movement of stock prices are not independent of each other. When the stock of SBI moves, the stock of ICICI will also move because there are many business links between them. They happen to operate in the same financial sector. They are both banks, so their movements are not independent. They are influenced by the same events, same news items, or same market situation. And whenever we talk about dependence, we immediately think of correlation. So we will try to look at the correlation to get an idea about how this dependence works out in data. And remember, sometimes you may not have correlation to work with, like in the Cauchy distribution case. What will you do then? You will need some other measure of association. Correlation is one linear measure of association, but it is not the only one. So if I do not have the power to calculate correlation, which it might be the case, I need to work with some other candidate. But let us look at the simple things first. This is a correlation matrix. So I look at a few stocks from the United States US stock market, and the correlation of their prices with each other are illustrated in this table. And you can see that some of these correlations are quite big. So this is a heat map kind of picture where larger numbers are in deeper colors. So of course, forget the diagonal because that has to be 1 by definition. But here I have 0.5, 0.46, 0.36, big numbers like that. So these are the correlations that we study, and these are the correlations which help us to model the dependence among the stocks in various ways. Because if I know about one stock more intimately, I can use that information to predict another stock price. And that prediction would, of course, involve a regression analysis. This is what we do it for. we want to make predictions, we want to make forecasts. And of course, the natural candidate for making predictions are regression models, linear regression models in particular. So I will mention two very important regression models in finance. One is called the capital asset pricing model, and the other one is called the arbitrage pricing theory model. So let us move to the capital asset pricing model, or CAPM. What is that?
Okay, one
Yes,
question is here is that what do we use when we can't find correlation? Yeah,
let's hold that question a little bit.
yeah. I think I don't know. Like one can always find a correlation, right?
If I don't have moments, how do I find correlation?
And do you mean does it mean the sample correlation?
No, sample correlation can always be calculated, but if I see that the sample moments are not stable, and also if I see that a very heavy-tailed probability distribution is matching the data, then should I trust the sample correlation?
Yeah. So he's telling that no, no, not if moment exists here.
Okay, so let us talk about the good case first, and then I will finish with the bad case. So what is the model? The capital asset pricing model is a simple regression model which tries to predict the return of a particular stock or a particular investment using information on the market index, which is the Nifty 50 in our context, and the bank rate or the risk-free rate. So this RF is the bank rate, ERM is the expected market rate. So this difference between the market rate and the risk-free rate is called the market risk premium. So what I try to do is I try to predict the expected return on the investment using a regression coefficient beta, which is nothing but the regression coefficient of Ri on Rm. So it's a simple y equal to a plus bx regression model, where x is the market risk, a is the bank rate, and y is the expected return on my investment. So this simple regression model also happens to be the most popular regression model in finance, called the CAPM, used a lot. And these betas are of course calculated using these correlation coefficients in this matrix here that you see. So of course you need the covariances to calculate the regression beta, and that is exactly how it is calculated.
Uh, can you go back to that once again, CAPM? I have some question.
Yes, CAPM.
Yeah. So this beta I. So ERI is the I is the index for what?
I is the index for my investment, RI, return on my investment.
Okay. So like how is the data collected? Like you made 5 investment and based on that data is collected. Like what is the data behind it?
So the data is very simple. The data is exactly what you see here on many stocks together.
Okay.
So this is only one Nifty 50. This is like your market rate, because it's a very good indicator of the whole market. But as you know, I have told you, I can change this here and look at some other index also, or I can look at individual stocks. That's how I will get the data.
Okay. So yeah, the data is the investment is which data over here? Like
The investment has happened in the past. So I look at the performance of my investment over time, and I try to predict. I want to make a prediction for tomorrow. So the main question is, when should I sell off my investment, or when should I buy more on my investment?
okay, fine.
That is always the fundamental question.
Yes, I think I am getting some like some question over here is that
Mhm.
this how we can get this data of ERI and ERM and the risk-free rate, and how is the bank related to it?
Uh,
This I think this is not getting to my head.
the bank rate is also available on the Reserve Bank of India website. It is generally kept constant over 3-month periods, so it does not have to be every day. So if you check it once every 3 months, that would be enough.
So I mean, you get
The
like
importance,
X profit, you get
the
a bank extra
importance
profit out of that.
exactly. So the
Okay.
importance of the bank rate is that the easiest thing you can do is put your money in the bank for a fixed deposit.
Yeah.
If you want to get more, you will have to take some risk, because you may get more in the stock market, but the stock market is also volatile, so there are fluctuations, so there might be some losses, some profits. So if you want to get more expected return, you will have to accept some volatility, and that is
Okay.
the relationship that is model like CAPM gives you.
Okay. Perfect. And I is indexed by time.
I I is not indexed by time. I is indexed by the particular stock I have invested in.
Okay.
The time index I have not mentioned here. That will be for all of these, both for I and and for M. So I will
Okay.
need
Okay.
data over a time period for both of them, and then I do the regression analysis.
Okay. So, my I have a simple question over here. Is that the this regression, this beta I may not be constant over time, right? Like it may be different with respect to time. So, how
Yes,
can
it's
we
the
make
same.
sure that suppose I take the data of various like sort of different time points, how can I make sure it will give one single beta
I'm
i's?
not
So,
sure. I'm not sure. This is the simplest model, and that's why it is the
okay.
most popular. But of
So
course, you
this
can
is the
have a,
idea.
this is the
So we
idea,
get
and you can build
this
on
is the
it.
idea we okay. This is the idea we take some initial at random points in the suppose we take certain stock, and of that stock we're taking random time points and we're taking the data of the time points, the opening price and the closing or whatever the gain is, what we are investing and what is the output, and we are taking that and making a linear regression on it to calculate the beta I. Right.
Yes.
Okay. Perfect. Yeah. Thank you, sir. Yeah.
So, so I will move on to an extension of this model.
Yeah, I is for particular stock. I is the point where it is invested. Every new transaction is happening. So yeah,
I is the
done.
stock where I have made my investment. So I am tracking the price of that stock closely, and I want to find a good predictor for it using the market index.
Yep.
That's the main
Oh,
problem. It's the same problem for every situation. Even when I go to this next model, which is the arbitrage pricing theory model, here also I am still interested in this return. But now, instead of looking at one single factor, like the market factor here, I may look at various other factors. So here, arbitrage pricing theory model is just an extension of the CAPM, where instead of one single predictor variable, I can look at 10 many predictor variables, and I fit a multiple linear regression model. So in short, I have this RP, which is my risk premium with one particular factor P. The corresponding regression coefficient is beta T for RI, and I can have many of them together. So a multiple linear regression version of CAPM, where I choose my factors carefully, is called the arbitrage pricing theory model.
okay.
What are the
So
possible factors?
beta
Yeah.
I is therefore is based on those correlation matrix that you have shown of those two
Yes.
prices. Okay, fine. Now it makes sense. Yeah. I hope all of the students over here it makes sense. If you don't, like, I will explain in the classes. Like if you have any other
Now,
queries.
what are the possible factors that we are interested in? So if I am trying to make a good prediction for the stock price, I may want to look at the national income, which is the gross domestic product growth. I may look at the bank inflation rate. I may look at prices of gold, because gold is always an important investment avenue. I can look at other market indexes like the Standard and Poor, and of course, I will always look at the bank rate. So there might be multiple factors which are actually influencing the price of a particular stock. So instead of looking at a single variable regression model, I may want to generalize that to multiple factors, and that is the APT model.
Perfect.
Okay. So I think I will stop here accepting the questions. But before I stop, these are two books which might be useful to you if you want to pursue this line of study further. One is this book by David Rupert. This is the more statistical book. And the other one is by Sheldon Ross, who has written those fantastic probability and stochastic process books. He also has an elementary introduction to mathematical finance, which talks about all the nice models like the binomial model.
Yep. Yeah. Okay. So I think there is a small doubt is that in those models CAPM and APT I guess, or AP, is it
APT.
APT? Yeah.
APT.
So they are asking that is it the same stock or it is the portfolio of the person? I think the same stock,
It
right?
can be both. It can be both.
Acha.
I can talk
Okay.
about one single stock. I can talk about a combination of stocks. And the error term I did not write in the regression model, but it is definitely there. There is a question on that. Any regression model would have an error, and that's why there is a fluctuation. As I said, remember, if you want to have more expected return, you have to take some risk. And that risk is the variance of the error term.
Yep. I think so. Yeah. Any other questions, guys? It's now
Go back
open
to
to
this
the.
question on the modeling of volatility, correct? That was one question.
Yeah. Yeah. Yeah.
Yeah. So if you want to know more about that, you will have to look at the volatility models in time series. In particular, you can Google the term GARCH. If you Google GARCH, you will find more than enough material to look at.
So what is the Gurch? Okay, Gurch. Perfect.
It's an abbreviation, so find out
Yeah.
about it.
Okay,
The other
Sananyapan is
hedging. I think there was one question about hedging,
yeah.
correct?
Yeah, Ananha, I am coming to that. Ananapan was asking that what to do when we can't find the correlation in case of those betas, if what happens in those when like
Good question. Uh, so, do any of you know any other measure of association other than correlation? There are other measures for association. Any names that you can recall?
yeah, they are telling about the categorical ones.
Yes, there are a few categorical association measures, and if you do not have the mean, which means you do not have correlation, then those are the candidate measures that you go to.
So you
Yeah,
distribute into various
common
parts and
answer
you
is
take the
Ewell's Ewell's measure. I think Anannapam Day, is it? Yeah.
yeah, yeah, yeah.
So there is a Kendall's tau, there is a Ewell's measure. So these are measures which will work even when the usual correlation doesn't.
Yep. So yeah, another part is hedging. Another question was hedging by Bhakti. So yeah,
Hedging is
can you?
a relatively more complicated topic, but I will just tell you the following that okay, instead of one single stock, I focus on two stocks together. And I try to find a situation where I buy one stock today, which is currently cheap. I sell the other stock, which is currently more expensive. Tomorrow, I expect the cheap stock to gain in price and the expensive stock to lose price. So I will do the reverse transaction tomorrow. I will sell whatever I have bought and I will buy back whatever I have sold today. In the process, I will make a profit. So I do not use any money from my pocket. Whatever I get from the selling of a stock, I use it in buying. Tomorrow I reverse it. If my prediction is correct, I will have made some profit without investing. That is hedging.
Yeah, perfect. Any other questions, guys? It's a really beautiful session. Thank
Thank
you,
you.
sir. Yeah, yeah. I will just. I'm just waiting for the other exciting questions they have in their minds.
Yeah, so if there are questions, of course.
Yeah, I
Yeah.
will also ask sir, and we will take the links from sir, and I will mention it in the description. Uh, yeah, is risk same as volatility? Hemant is asking.
Volatility is one way of measuring risk. Risk is a broader term. Volatility measures one aspect of it.
Yeah, people are asking if you can share the PPT. I'm not sure. It depends upon sir. I think he can give the
Yeah, so the PPT is
PPT.
already with you. PPT is already with you, Sujit, right?
Okay, I can share it with them.
Yeah, yeah, of course.
Okay, lovely. Okay, so I will share the PPT with you guys. That's in the group, of course, and yeah, I hope yeah, people are motivated by Warren Buffett over here. Yeah, that's
Yeah,
good.
we can see that. Good. So anyway,
Yeah,
first of all, start enjoying statistics. This is one
yes.
very nice application avenue for statistics. And if you are really interested in finance, then start working with the data and you will pick it up. There are a
Yep.
few technical terms which you need to learn, but it is not the important part. The important part is your sense about the data. So if you are comfortable with data, you can easily do this.
So, what will you suggest, sir, to those who are planning to pursue? This is the last question, I guess, from my end for my students. Is that what is a thing you will ask them? Like, what is the suggestion you will give to the students who are planning to pursue statistics and finance together as in their future, like in academia as well as industry? What will you suggest to them?
Suggestion as in what to do or what to study, what kind of.
Where to study and yeah, what to do, yeah, whatever.
Well, I think what to study, the very good places would be ISI, of course,
Yeah.
and also CMI. These two are the best places I know in the country where you have a very good combination of statistics, mathematics, and finance. IIT Bombay is a possibility also.
So yeah. Yeah, perfect. You got the answer, guys. And yeah, it was really nice session, sir. Thank you so much. I also learned something new as a student. I will also use this in my own classes too. And yeah, thank you, sir. And I look forward to other sessions with you soon. Thank you so much.
All
Good
right.
night, guys. Yeah, bye bye. And people really love your cheerful attitude. So yeah, yeah. Thank you so much, guys, for being present. Bye.